Voyager 1 is sending strange signals beyond the borders of the solar system. The terrifying new signals are unlike anything ever seen before. Scientists are puzzled. Are these signals a hidden clue to unexplored mysteries in interstellar space, or is the probe just malfunctioning? In 2021, NASA already had to deal with confusing data from Voyager 1. The data sent was puzzling, but it was supposedly a defect, and scientists brought the probe, which was already well over 20 billion kilometers away at the time, back into line. Now the game seems to be repeating itself, but this time everything is different, say NASA technicians. Is Voyager 1 really lost forever? Voyager 1 is so far out in space that it is almost 6,000 times the average distance from the Earth to the Moon. More than 45 years have passed since the space probe set off on its iconic mission in 1977, and the probe and its identical twin, Voyager 2, have explored areas where no man-made object has gone before. Voyager 1 was the first human probe to reach Jupiter in March 1979. There, it took the first detailed images of Jupiter's turbulent atmospheric patterns, including the Great Red Spot, and provided fascinating insights into the diversity and activity of its moons. Since then, we have known about volcanic eruptions on Io, and we had the first evidence of subsurface oceans on Europa. After the successful exploration of Jupiter, Voyager 1 flew on to Saturn. The probe mapped Saturn's impressive ring systems and discovered the fine structures within the rings. It also took the first close-up image of Titan, Saturn's largest moon, and revealed important data about its dense atmosphere, prompting scientific speculation about Earth-like fluid cycles on the Moon. After these groundbreaking discoveries, Voyager 1 continued its journey past the outer planets on a path that would eventually take it out of the Sun's sphere of influence and into interstellar space. That was in 1980. The probe then flew through the Kuiper Belt for 10 years before finally reaching the magical threshold of open space. After another 12 years, on August 25, 2012, Voyager 1 was clearly visible in interstellar space for the first time, and there were some surprises waiting for the researchers, signals so strange they shouldn't exist. What was really going on when Voyager 1 measured a sudden stream of particles in interstellar space? Particle streams in open space should not actually be so close to our solar system. Scientists suspected that the stream could have originated from a distant event, such as a plasma ejection from a star. However, it would be highly unusual for such streams to travel so far into interstellar space and be carried so far by it. You must realize that the closest star to the location where the mysterious stream was measured is more than 4 light-years, or 37,842,921,890,333 kilometers away. A plasma ejection stream at this distance should have long since dispersed within the emptiness of the universe. Many scientists therefore doubt the theory and concede that we could be dealing with a mysterious unknown force. Some daring scientists have even speculated that the particle stream could indicate activity from extraterrestrial life forms. Surprisingly, Voyager 1 showed that the overall particle distribution in space is much denser than previously thought. This may not sound very exciting at first, but in astrophysics, just a few particles can change our entire picture of the universe. One of the most striking features of interstellar space is the significant increase in cosmic rays. As expected, Voyager 1 recorded a significant increase in the intensity of cosmic rays. This observation provided important information about the composition and dynamics of space beyond our heliosphere for the very first time in human history. The data from Voyager 1 also indicate that the interstellar magnetic field is stronger and has a slightly different orientation than expected. These findings are not only forcing scientists to rethink their models of the interstellar medium and the interaction between the solar wind and the interstellar medium, but we may have to rethink the entire map of our galaxy. The magnetic fields in the interstellar medium play a crucial role in the dynamics of galaxy assembly and star formation. Some theories even suggest that the magnetic fields could also be remnants of a primordial magnetic field that emerged shortly after the Big Bang. These original fields could therefore still be magically effective primordial structures that carry the developmental processes of the entire universe within them and are therefore messengers of cosmic history. Why is Voyager 1 so long-lived? It was a memorable day in human history when a Titan IIIe Centaur rocket launched Voyager 1 into space on September 5, 1977. No one thought it would be more than 45 years in the future. At the time, the scientists wanted to take advantage of a unique conjunction of the outer planets, which only occurs every 176 years, to send the Voyager probes to the then still largely unknown planets. The first target was the gas giant Jupiter. Voyager 1 arrived there a little earlier, although it was launched later than its sister. This was because Voyager 1 had taken the more direct but also more dangerous course through the asteroid belt between Mars and Jupiter, while Voyager 2 was accelerated along slightly different orbits. Both Voyagers also stopped by at Saturn, after which they parted ways. While Voyager 1 set a direct course for the end of our solar system, Voyager 2 delivered the very first images of the planets Uranus and Neptune. The scientific and technical successes of the probes in the 1980s were already overwhelming. The fact that Voyager 1 is still functioning and transmitting scientific data well over 45 years after its launch is nothing short of a miracle. The Voyager mission was an open-ended adventure. At the time, NASA was already planning a further flight into the Kuiper Belt and possibly even further, but whether the probes would actually arrive was written in the stars. The fact that both probes reached open space is an iconic achievement, and they could continue to deliver important data for some time if something hadn't happened that scared NASA. Is Voyager 1 about to end? It was the nightmare no one wanted to experience. In the middle of one of the most exciting phases of the mission, Voyager 1 reported a disaster in May 2021. It looked as if Voyager 1 had completely lost its orientation in space. But then the engineers noticed that although the probe signal was going crazy, it was surprisingly consistent. If Voyager 1 were tumbling around in space, the signal would arrive with interruptions because the probe's antenna must always be pointed strictly towards Earth in order to transmit the signal over the long distance. If the signal arrives, the antenna must also be correctly aligned, and consequently, the position of the probe in space must still be stable. So where did the crazy telemetry data come from? For weeks, there was confusion. Signals were coming in, but they made no sense. The mood at NASA was one of crisis. Dozens of engineers set to work studying old construction plans from the 1970s, bringing long-retired technical staff out of retirement, and finally, a solution was found. Telemetry data is essential for monitoring and controlling spacecraft, as it provides information on the status and health of the various systems and instruments on board. An analysis showed that the faulty telemetry data came from the Attitude Articulation and Control System, AACS, which is responsible for pointing the spacecraft in space. As the antenna was correctly aligned, the program of the control system must have somehow got mixed up. It was agreed that the AACS may have started sending telemetry data over a path or channel not intended for it, which then led to the illogical data. The challenge was to fix the problem from billions of kilometers away. One wrong instruction could have made the problem worse and rendered the probe useless forever. The team worked feverishly to find a solution and decided to reroute the internal controls to an alternative system to see if it would work again from there. As you can imagine, the tension was high. The order was sent from the control center in California. Engineers had to wait 20 hours for Voyager's response. Then came the relief. The plan had been a complete success, and Voyager was sending usable data again. Then came another shock in the fall of 2023. Once again, confused data arrived at the control center in California. Of course, the incident was immediately reminiscent of the problems from 2021, but something was different. The communication disruption occurred for the first time on November 14, 2023. Instead of normal radio contact, the probe transmitted a meaningless repetitive sequence of zeros and ones. NASA suspects a malfunction in the Flight Data System, FDS, which is responsible for collecting and transmitting data from the scientific instruments and status information from the probe. Experts have been tasked with deciphering the cryptic data. It was hoped that the data could be used to draw conclusions about the error, and they succeeded. An engineer from the Deep Space Network, over which Voyager 1 signals are transmitted, discovered that the jumble of ones and zeros was an exact replica of the probe's FDS memory. So, Voyager 1 was still alive, only the data was acting up again. Despite the glitch, the probe was able to receive and execute commands from Earth, further indicating that not all communications capability was affected. At the time of the video's release, the problem still persisted. Due to the long distances and software limitations, diagnosing and repairing the problem is again complicated. So far, there is uncertainty as to how the fault could be fixed this time. In NASA's latest statement, the head of the Voyager project, Suzanne Dodd, was not very hopeful. NASA is expecting the mission to end prematurely. NASA is currently gloomy about the chances of restoring the probe's ability to communicate, but Suzanne Dodd emphasized that the team has not yet given up completely and will try other solutions. They are currently trying to put the spacecraft into different operating modes to locate the damaged memory. Some of these operating modes have not been used since the flybys of Jupiter and Saturn over 40 years ago, which makes the endeavor risky. Click subscribe now and be part of every new video.